Hey guys, welcome to yet another video, second video on moments or turning effect of forces. Alright, I'm sure you've seen this before. Okay, unfortunately, we don't really have many of these in our playgrounds right now here in Singapore. I'm not really sure why, but probably safety is a factor. But I think if you've been to some other playgrounds, you may actually see some of these seesaws coming back. Okay, so if you played with seesaws before, like me, okay, what you do is you actually okay, this center point here is actually known as a pivot because it doesn't move. The seesaw is actually rotate either anti-clockwise or clockwise. It rotates about this point here. So if you were to play the seesaw before, you sit on one end, it will go down. Okay, you sit on the other end, it will also go down. Oh, but why does it go down the other end right now? Okay, because let's say if you are playing with a heavier person, this 20 kilograms, 10 kilograms, obviously the one with the heavier mass will actually cause the whole seesaw to go down, right? Okay, so how do you actually play this seesaw if you don't, both of you don't have exactly the same weight? Well, okay, that's why playing is fun, all right? So what you need to do, okay, if you are the lighter one, what you can do is you can start to move away from the pivot. So what happens when you move away from the pivot? Does your mass or your weight actually change the force? Your force still the same, right? But what is increasing here? That's right, your lever arm, also known as the perpendicular distance. So if I keep moving away from my pivot, I actually am increasing this lever arm distance until, whoa, boom, you see? My seesaw starts to move and until this, boom, whoa. Can see right now, I have exactly the same left and right. I have the same one. Do they have the same masses? Of course not. One's 20 kilograms, one is 10 kilograms. So they have different masses, different weights, right? Okay, but what about lever arm distance? This is, let's say, 1, 2, 3, 4, 4 units about this one. 1, 2, 3, 4, 5, 6, 7, 8. 8 units. So lever arm distance also different. Masses also different, but what is the same here? That's right, the one last row. Oh, you are right. Moment of the force is the same here. Why? Because as defined in the last video, what is the moment of a force? It is my force times the perpendicular distance. So let's say if I include this to be 20, 200 newtons times 4 units. Okay, just to put in a ruler so that it's easier to see. Excuse me. Okay, so 20 times 1 unit is the same as 10 times, how many units is 2? So 10 times 2 is 20. 20 times 1 is 20. So you can see my moment is the same. So if I want to move this further down, let's say 20 times 0.5, that will give me 10. So for here, I need to get a value of 10. To get a value of 10 will be 10 times what? 10 times, that's right, 10 times 1. You can see here, it's the same, right? Okay, just to make things a little bit more interesting, let's see if I want to add something here. How do I actually increase it? Okay, so you can see if I have a 5 kilogram mass, whoa, that's right. So 5, wow. So what's happening here? You can see 20 times 0.5. Okay, clockwise movement will give me 20 times 0.5, which is 10. 10 plus 5 times 2 is 10. So this whole amount is actually 20. 10 plus 10, 20 plus 10 times 2 will give me 20 also. Okay. So this brings me to the new principle, all right, which is boom, okay, the principle of moments, okay, it tells me when a body is in equilibrium. Equilibrium means it does not rotate anymore, all right, that means it's balanced. The principle of the sum of clockwise moments about a pivot is equal to the sum of anti-clockwise moments about that same pivot. Alright, so what do we mean by that? Alright, okay, so let me just show you a diagram of, let's say, like just now we had a seesaw. So let's say I've got an unbalanced seesaw over here. Seesaw doesn't mean the pivot all the way in the center. Sometimes I have a little bit off center over here. So let's say I've got 3 forces acting on it. two forces like F1 and F3 is pointing downwards, F2 pointing upwards. Okay, each of them with a distance of d1, d2, d3 from the force F1, F2, F3 to the pivot. Okay, so applying this principle of moments over here. Just now we talked about the principle of moments, right? Okay, principle of moments with sum of clockwise moments equals sum of anti-clockwise moments about the same pivot. So applying that here, what's happening? First thing, got to look at the forces and F1. We got to decide whether is it clockwise or anti-clockwise moment. Okay, so for F1, I know it's anti-clockwise. Why? Okay, so let's say, imagine this bar here. If pivot doesn't move, right? So if the pivot at this point doesn't move, the only way if I were to pull this down, the whole seesaw will actually move down. Can you see that? It will actually move down. So if it keeps moving down, this is anti-clockwise. All right. So what about F2 here? F2 is also anti-clockwise. Why? Because if the original position is here, I push it up and see this, the same thing. Pivot don't move. This part here, F2 it moves, so it moves up. And you see, it moves up. Check this out. And boom, moves all the way up. And you can see it's actually moving in a clockwise direction, right? Oh, sorry, I mean an anti-clockwise direction, right? Can you see that? Okay. And finally, F3 here. This is the only clockwise direction because if I have something that pulls it downwards, taking reference from the pivot don't move, the end moves down, so you can see it actually goes clockwise. Okay, right? So it doesn't really matter. It doesn't mean that force going down is always clockwise because you can see this one down is anti-clockwise, whereas this one down is clockwise. Okay, you need to reference it to the pivot. Okay, so the pivot always fix it. The other end where the force is applied, for example, F2, you got to move it a little bit. So by moving this a little bit upwards, you can see this actually goes in a anti-clockwise direction. Okay, excuse me. So we've got two forces that's anti-clockwise. That's why I have F1. Okay, in this case, I have F1 times D1 plus F2 times D2. This is my sum of anti-clockwise moments equals sum of clockwise moment. In this case, I've only got one, which is equals to F3 times D3. All right. So the rest is just mathematics. You can actually solve it. Sometimes they will actually ask you to find what is F2 or F1 or F3. Sometimes they will actually ask you calculate what's the distance that you need to sit in a seesaw or in a system so that becomes balanced. All right. Okay. Hope you enjoyed this video on principal moments. Okay. I'll see you in the next.